we can't. Hold on. Let me know if you can see my screen.
Yes, I can see yours.
Okay, so we are in the third module of this course. So now in this module we'll be talking about using functions and packages in R. So I believe I've gone through some things here before, but I'll just go over it again. Talking about using functions and packages. So here, what are we going to look at? Because functions are things you're going to be using very well, because some packages might not give us functions that we suit our needs sometimes. So we have to create our own what we call them user-defined functions. So in this object, we're talking about developing scripts and functions in R. Use arguments with functions, explain the function environment, explain methods with functions, and talking about packages, how to install, load, and unload packages for R. So, I've talked about this before in the previous class. So I'll just go into the practical aspect of it. So now, let's take a look at this. So I'll start from here. Now, we are trying to create a function called add%. Now, that's why it said add% is equals to, sorry, let me allow someone into the room. Okay, Titi is here. Okay. So here we are trying to create a function called add%, which is a function of x. So you use the function keyword to create the function. So function of x. So the x inside that function is the parameter the function is going to be taking. So it's going to take a parameter called x. So x can be anything. So it depends on what kind of thing you want to perform on x, especially. So now, here, see, now inside the function. So after the function into bracket x, I have a curly brace opened. So inside that curly brace is what you are going to write, what the function is going to do. So that's what you do inside the curly brace. Now, inside the curly brace, I'm saying percent is okay. Percent is round into brackets x times 100, comma digit is equals to 1. Now x is our input as part of the parameters of the add%. So we are saying that we want to multiply x by 100, then round the result to 1 decimal place. That's why the round function is here. So round x times 100 to 1 decimal place, then assign the result to what? The percent we are seeing to your left here. Then on the percent, on this percent that is on the second line here, we want to paste it together with the percentage sign separated by an empty space. I don't want a space at all. So that's why you see the quote does not have a space. So let it be together. So if I have %50, add the percentage sign together with it without leaving a space. Then return result, that is print the last statement, which is the result that I said should paste. So return it. So that's going to, so that's obviously going to do x times 100 rounded to 1 decimal place. Then the result is going to be pasted together with the percentage sign. So that is exactly what this function is doing. Now, moving to the next slide here, we are talking about the ls command, which is used to see the object you have created so far in the R session. So let's try and perform a simple function. So I won't just do what was displayed on this my slide here. So let's quickly do a simple function. So here I'm going to do something like, let me open a new file. Now we want to create a simple function. So here I'll call it what should I call it? I'll call it f1. That's the function I want to create. I'll say is equals to function into bracket, then sorry, function is not complete. Function into bracket. Then what are the parameters? What are the variables I'll be using? I want to use two variables called x and y. So I'll put x, y in this manner. Then what do I want the function to do? That's going to be written inside the curly brace. So I'll put the curly brace. You can see it's open this curly brace and close it for me, but I'll just press enter to go to the next line. And I'm going to write whatever I want the function to do for me. I can say, okay, I want to create another variable called add. Let me say add, underscore x underscore xy. Add underscore xy. I'll now say add underscore xy is equals to x plus y. So I want my function to add x plus y together and what assign it to what a variable called add underscore x plus y. So the next thing is that I want it to print that variable add underscore x plus xy. So I will create this function by I can run this control enter like this, or I highlight it like this and press control enter. So control enter, we have created the function f1. Now if I want to use this function, I just have to say f1, then into bracket. Now remember, it's taking two parameters, x and y. So inside this bracket, it means I have to put two parameters. Since it's adding two numbers together, I can say, okay, let me to add 5 and 2.3. So I'll put 5, 2.3 this way. I can separate the space, it doesn't matter. I might not put space, it doesn't matter. So if I run this now, doing control enter, I'm supposed to get 5 plus 2.3, which is 7.3. So let me run it. So as you can see in my console here, I have 7.3. So let me allow someone into the class. Who is that? Okay, Bello Faida is here. Welcome, Bello Faida. Welcome. Going back to my screen again. So I believe you understand what this is doing. So it's just adding two variables x and y, and it's going to return the result to the screen. That's what this function is doing. So it's just as simple as that. You can create any kind of function to perform any kind of operation depending on the task you are trying to solve. So okay, now moving forward, let me go back to the screen again. I said using the function object. Actually, I think they wanted to say using function as object. Now I can assign a function to another variable, and that variable is going to be doing the same thing as what my function is doing. So for example, in this case, you can see that the add percent function that was created in the previous slide was assigned to a variable called ppaste. Now, as this function has been assigned to this ppaste, it means that the characteristic of add percent has been given to ppaste. So it means anything add percent can perform, ppaste would also be able to perform it. So that is exactly what that will do for you. So going to the next slide here, you can see that this is ppaste anyways. So I think this one does not have any significance. Now here I think I explained also this one in the previous class. So I think there's a... Hello, Bello. Hello.
Yes, I can't see anything. I can't see the screen.
Oh, you can't see the screen. Titi, you can see the screen, right? Okay. No problem. I'll just have to reshare my screen now since you can't see the screen. So I'll try to reshare my screen now. I want to stop sharing.
Okay.
So I'll stop sharing. Then I want to reshare now. Okay, I'm sharing my screen now. Please confirm if you can see my screen.
Can see your screen.
Okay. Faida, can you see my screen?
Not yet.
Titi, can you see my screen?
Yes, I can see now.
All right, fantastic. So now, in this slide, we're talking about reducing the number of lines. So there's so many ways you can reduce number of lines. You can reduce number of lines uh, by not including some lines. Some lines are not really significant. And another way, you can also drop the braces and write your function in a single line. But it's usually very uh, uh, professional to write your functions using a brace. So it's going to be readable in that format. So, but then we can actually do without it. Now, so let me go to that function I created before. I'll try to reduce the number of lines of this function and still achieve the same result. Now, this part that I wrote print add underscore xy, I can do without it. Now, I'll remove this part now. I've removed it. I've saved one line. So for it to print this result, I won't assign it to add xy. So it means I have to remove this part also. So I'll just be left with x plus y only. If I do this, it's going to perform the operation and I'm going to see it on my screen without using the print. So let me run it. Let me highlight and run now so that it's going to update my function with this. So I've highlighted it and I've run it. You can see it in my console. So let me run this command again. This F1 5,2.3. So as you can see, I still have 7.3 as my answer. It still perform the same operation for me without so many lines. Now again, I can remove this brace. So I want to remove this brace. So I'll remove it now. I will remove this one too. Then I will take this x plus y to the first line. I'll put a space. I've reduced my function from at least, I think, 4 line of code to like a single line. So let me run this now. So I've run it, as you can see here, I can see on my screen, I've created the function. So let me run this command again. This is my F1 5,2.3. Let's see whether it's going to give me the same result. As you can see, I still have the same result, which is what 7.3. But then, as I said earlier, it's always good to have your braces when you're creating your function. It makes your code readable and it will make it difficult for you to understand when you have a challenge. So it makes it readable and professional. So, all right, moving forward. Do we have any questions as regards that? Before I proceed. Okay. Um, Going to the next slide. Here they just applied some little stuff to the function to make it dynamic, but I won't go into this until we get to some part of this course so I can get it better. No, okay, let me just give an overview. So what they're trying to do here is that add percent function they created, they're trying to check. Don't just perform the operation. Now, for a particular x, if a user is trying to use this function, and this function is supposed to work with numeric values or vector of numeric values, like a vector that contains numeric values. Now, we're trying to check, maybe a user does not know what the function is doing, and the user inserts like a character variable. Now, it means that the function is going to pop up with an error. Now, here we are trying to say if is not numeric. Now, is.numeric function is going to return a logical value. So this exclamation sign is trying to negate the logical value. So it's checking if it is not numeric, return null. That is, first of all, check if x is not numeric, it means I cannot perform the percentage operation on it. So I will tell it to return null. Instead of it to return error, it's going to return null. Else, So after an if statement is going to be the else statement. Else, then it's going to perform this operation and return the result. So let me allow someone into the class. They both just like that. Okay. So moving forward, we have this. So this one is just talking dropping the braces and give us an instance of dropping the brace. So after the function, the space, then the operation you want the function to do. So let's move on to the second slide. Hello, Bello, can you hear me? Bello Faida. Hello. Okay, she's already in. She should hear. All right.
I can hear you. I was thinking, I
Okay.
was muted.
All right. You can see my screen too, right? All right. Okay. Now using arguments. Arguments are these x and y. For example, when I was creating this function f1, the arguments there are x and y respectively. Okay. Now let's see. We can add more arguments to our function. Now, the function that was introduced in the previous slide was taking only one argument x, and I've shown us in this R session that we can take more than one argument. Here, this function I'm showing you is taking two arguments x and y. I can have more than two, depending on the task I'm trying to solve. I can have more than two arguments. So now moving forward, here they added another argument called mult argument, like mult. So this function is no longer taking one parameter, it's taking two parameters, x and mult. Then they are using the both of them to work on the function. So what is this one doing? It's saying multiply x and mult, add it up to 1 digit, and paste it with the percentage sign. That is what it's doing. So it's not something that is difficult. Now, also, you can add a default value. Now, this is also an interesting part. You can add a default value. So I will explain this. Now, this is a case scenario. Now, here when they were creating the function, they defined two parameters, x and mult. But the mult argument was assigned to what? A value 100. Now, this part whereby they assigned 100 to value mult. Sorry, if you are not talking, you have to stay muted. Then I have to mute you. So whenever you're not talking, just mute your mic so to avoid interference. Now, moving forward. Now, the mult value is assigned 100 in this case. So what it means is that in this function, after I've created this function and you want to use it, now it is not compulsory I give the second parameter a value. So if I don't give it a value, how is just going to use the 100 that you have specified when creating the function? So it's going to take the default value. Now, but if you give it a value, it's going to use that value it was given and it won't use this 100. So it doesn't mean it's a constant. It doesn't mean that mult must be 100, but it's just a default value that whenever the mult parameter is not given, then it's going to use 100 to perform the operation. Because as you can see in the function, the mult argument was specified, so it has to use it. So, but in this case, it has a default value of 100. So let me demonstrate it with this function I created. So here I'm going to put y to be, let's say 2. No, let me say 10. Then I'll create this function. Now I can exclude, here. Now your function, your argument follows the order of the function you create as you created it in the function. X comes first and y comes second. Now, but it doesn't matter the arrangement. But if you don't want it in that arrangement, so if I write it like this, it's going to understand that x is 5 and y is 2.3. But if I want x to be 2.3 and y to be 5, I have to specify inside the function that y is equals to this and x is equal to this. It does not follow the arrangement now, but how is going to understand that we are taking this for x or taking this for y. But if I don't put this, then R is just going to say that, okay, we are trying to say that x is 5 and y is 2.3. So she understand that. Now, if I should run this command down, it's going to give me 7.3, as you can see. But I created y to be what, 10, but it didn't use 10 because 10 is the default value of y. But I already specified value for y here, which is 2.3. So it's going to use that 2.3. Now, let me remove this 2.3. If this 2.3 was not given, it's going to take x as 5 and it's going to pick y to be 10, which is the default value. Then it's going to do 5 plus 10, and that's going to give me 15. So if I should run this now, you can see I have 15 here. Now let me now come here and put y is equals to 5. If I put y equals to 5 here, you know the parameter x now is not given. If I should run this, it's going to pop up with an error. So let me run it. As you can see, error in this argument x is missing with no default. It's saying that you didn't specify argument x and there was no default value for it. So you don't expect me to perform anything. What do you want me to do? I'll come with an error. So it means you have to check what you just did. So that is basically that. I hope you understand before I proceed in this course. All right, I think I believe that was well simplified. So moving forward, now using the dot argument. Now this can be complicated sometimes, but it's very easy. It's not difficult. It's not even difficult. Like, it's just super easy. But then, if you don't get the logic behind it, you might find it confusing. Now, what's the essence of this dot dot dot? Now, I don't know whether I should say this in mathematics then, or might not necessarily even be mathematics. Even in normal chatting, sometimes if you write, you're writing a statement and you put dot dot dot, it means there are still some information that you didn't include. Maybe something continues, like there's still something left. So in mathematics, I can put 1, 2, 3, 4, 5. Then maybe I want to write 1 to 100. I can just put 1, 2, 3, then comma dot 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 comma 100. It means I'm telling you that there are still some certain numbers, but I'm actually going to 100. So this dot 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 means that, you know, inside the function is very specified the argument. Now in this function, I have two arguments, x and mod. So the dot 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 means that I can still accommodate some parameters, but they are optional. If they are not being specified inside the body of the function, it won't be used. They won't be used. Now, as you can see inside the body of this function, I use what? Round x times mod, comma dot dot dot. Now, it's, you know, round can take two parameters, the operation and the number of digits you want to round your the operation. Maybe you want to round to 2 decimal places or something. Now this dot 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 give room for, if I specify a third argument when using this function, it means that third argument will be used in this second line. So if I specify 3 as the third argument for this function, it's going to round x times mod to 3 decimal places. But if I don't specify, it means it's not just going to use it, it's just going to find x times mod and just move on. So they are optional. So they are optional arguments that you can use whenever you want to accommodate some other parameters depending on what you're trying to do. So that's just the essence of that. I hope that is well simplified, or do you still need clarity on that before we proceed? Okay. Moving forward. Now, using function as arguments, you can also pass functions as arguments depending on the kind of task you want to do. It's accommodating. You can put a function inside the function. Now, let's see an illustration. As you can see here, I'm creating a function with three parameters: a parameter x, a parameter mult, which has a default value of 100, and another parameter called fun. Now you can see that fun is taking round as a function, as a parameter, and round is a function itself. So it means you have a function inside the function. So you just assign the function as an argument inside the function. So it's allowed. So you can see here in the second line that percent is equal to what? Fun into bracket x times mult comma dot dot dot. It means that what the round function is doing, fun can do it, because we already said fun is equal to round. So fun can do what round is doing. So it's just as simple as that. But then you don't want to do this in some cases, like even most cases, because you don't want to assign uh, an inbuilt function as a variable. You don't want to assign an inbuilt function an inbuilt function as a variable, because you don't want to confuse fun as one function. So it's not actually professional doing that. But you can use function inside the function. So also this one is talking about what's using anonymous function. Uh, what are they trying to say here? Okay, so in here, sorry. I think they used what's it called? This the previous add percent, which takes fun. Then here it just, oh sorry. And here what you just did is that they said add percent and they specify the particular profit. The profit function has been created. Sorry, the profit variable has been created as a vector of these numbers. Then I say, okay, perform the add percent function on this profit. Then they now specify fun as what? This function. They now modify fun inside the function again. You know, fun was used as a round function, but they now modified it here, which actually performed the operation inside this function. It just took x as profit, then I perform this and move on to what? To paste the results. That's exactly what it just did. So you might be creating functions not as complicated as this. So depending on how you really want to what's it call it? Create your function. So also now let me take this knowledge check. Now here I said you want to add a new argument sub to control the subtraction factor in the function named cow. Which of the following commands of R would you use for this purpose? Now, the first one is not correct. Now, why is the first one not correct? Because if you are creating a function, you can't have brace starting the function. It's very wrong. So that one is out of it. Now, the third one here, there is no way I'll be creating function and say calc comma function. No, I will say calc, then I will put the assignment of sign or operator, that's less than and minus sign, and say assign it to the function. So this is the third one is also out of it. Now the last one is calc greater than. It's not that way. That's not how to use the assignment operator. So those three are wrong. It means the second option is the right answer here. So moving to the next slide. Now, scope of functions. You have external and internal functions. So let's talk about this briefly. Now, talking about external functions, we have what we call the global environment. So we have what we call global environment. Now, global environments are anything you create outside the function. So let me put that way. Anything created outside the function is a global variable. Anything outside the your function is the global environment. Inside your function is where you have your local environment. Now, your function can have access to the global environment, but you can't have access the local variable inside the local environment. That is, I cannot use have access to variables created inside the function. I don't know whether I'm confusing some people here. So as I was saying, so I will explain this further in the next slide. You get the concept. Now in the next slide, okay, let me move forward. So they didn't show me that. So let me give an instance. Or this is my house. Then this guy x is equal to 5. I created x is equal to 5. If I should call x, I will have x to be 5, right? Good. I will have x to be 5. As you can see, uh, in my console here, that x is 5. Now I want to what is it called? So I want to create this function. I want to run this function. So I want to run this function now. I will use the parameter 2, y is equal to 5. Now, in this function, I have two parameters x and y. Now, I'm running this function and I'm specifying x to be 2 and y to be 5. It means that I'm supposed to have what? 2 plus 5, which is 7. Now, if I should run this now, what do I have? 7. Now, if I should call x, what do I have? 5. Now, x is 5. So, the x that is being used inside the function is a local variable. So, it's going to use the x that is inside the function, not the x that is outside this, what's it called? Outside this function. So the variable inside the function is called a local variable, while the variable outside the function is called a global variable. Though a function can have access to what's it called? Can have access to a variables in the global environment. So let's say, for example, I have f2 equals to function what's it called? So let me specify. I don't want to put any argument. I will now say x plus 10. I will now say x plus 10. I will now say x plus 10. Let me run this. Now it has been created. So let me do f2. Let me run f2. You know, my f2 does not have a parameter. So let me run f2. You can see it gave me what? 15. So what just happened? My function just accessed a particular x in what? In the global environment to perform the operation. Now, if I should remove this x, let me remove this x. I've removed the x using the rm function. Now let me run my f2 again. You can see error in f2, object x not found. Object x not found. So it means I can't use this guy. Now I want to give an instance now. That inside this function, I will create a particular x. I'll create another instance. Say x is equal to 5. Now, after x is 5, now do x plus 10. Let me try and run this one. I'm not going to create an error because of this space. Yes, I know I'm going to get that. So let me just put it inside this. So I'll put it inside this so that I won't have this issue. So let me close this. I'm going to run this again. Now I've run it. Now if I run my F2 now, I'm going to have what? 15 because I assigned x to be 5. Now outside my global environment, let me assign x to be 10. If I should call x, what is x? X is 10. Now let me run F2 again. What's F2? 15, which is what? This 5 plus this 10. So why didn't F2 do take this 10 and add it with this 10 to make it 20? No, it's going to use the guy inside its local environment. So peradventure, if this particular X was not defined inside the local environment, then it's going to look for another X that is in the global environment to perform its operation. But if it doesn't see it, then it's going to pop up with an error. So as I said earlier, the local environment can access objects in the global environment. But so they let us get it twisted anyway. So moving forward. So we can also use create a function inside another function. So this is an instance. We created a function called calculate.f, which is a function of what x, y, and control. It has 3 parameters: x, y, and control. Now inside that function, we could see another function being created called min.base. And min.base is a function of what z. That's just a parameter, a single parameter. Now, what is min.base doing? Min.base is doing what? Z minus min control. Now, control is a function of what? Is a parameter of what? Calculate.f. Control is a. Hello, can you hear me? Hello.
Yes, we can.
Okay, moving forward. Now, control here is a what? Is a parameter of calculate.f. That means that min.base at the point is going to use calculate.f. Now after this, we are saying that min.base into bracket x divided min.base into bracket y. It means that is what is going to return at the end. Now, this thing can be complicated, but it's simple. Now, I'll explain how it's going to do this for you. Now, in this next this bottom of my slide here, you can see 3 vectors are being created: half, full, and nothing. Now you are saying calculate.f half, full, comma nothing. Now half will correspond to what? X. I mean, in that order. Full is going to correspond to my variable y, and nothing is going to correspond to my variable control. Now, how is it going to come about these figures here? Now after you have inserted this inside the calculate.f function, it's going to go inside. Now, what's inside the body of the function is another function called min.base. And what it's going to do is that it's going to take what's it called? Z minus min of control.
Who is going to supply the argument Z?
Okay, who's going to supply the argument Z? Yes, obviously is going to be okay. So yeah. Now in this, what's it called? In this last line, can you see min base x over min base y? Now min base x is what? Now the x there, you know, min base is a function, and you are saying to find what min base x divided by min base y. Now min base x, what is it going to do? It's going to use min base function, and how it's going to do? So x here is going to be my z. Now x has already been provided by what? Calculate.f. So it's going to do x minus min of the control, then divided by what? Y minus min of the control. That is exactly what it's going to do. So it's going to do my x here corresponds to what? Half. Then it's going to do minus, so half minus min of control divided by full minus min of control. That's just the basic thing it's going to do there. Do you understand?
No, please, Erika, please.
So in this place, you are saying that it should do what? Min base x divided by min base y. Now, min base is a function that takes a parameter z. Now, x here is what? Is already an input to what? Calculate.f. And what are the inputs that was provided? Half, full, and nothing. So it means it's going to do half. So x here is going to be like the z here. It's going to be as z here. So x, which is half, is going to do half minus mean of control. Control has already been provided as what?
Sorry, can we take this script to the half
Okay, let's do that now.
and practicalize it?
So I have calculate. So let me just shorten it. So that will be function of x comma y comma control. Then inside this body of this function, I have another function called mean dot base. That's going to take a so it's going to be a function of a particular z. Then what is this guy going to do? It's going to do z minus mean of control. And outside this, what's going to happen? So I'll come outside this base. I'm going to have mean base or mean dot base of x minus mean dot base of y. I'm going to create this function now. This is exactly what you have. So I'll create this function now. That has been created. So I'll create the three parameters we're going to use. So I'll say half. So I'll use the variables they use the half, full, and nothing. So half, I want half to be a vector of 1 to 5, and full to be a vector of, let's say, 6 to 10. Then I want this one to be a vector of 0.1 to 0.5, and let it increment by 0.1. Okay, so I'll highlight this. So they have been created. Now let me now run the function. So calc.f into what? Half, this is my x, comma, full, comma, nothing. This is my z. So I'm going to run this now. It came up with a warning. Oh, sorry. It's because this half is of length 6. So let me put 6 to 10. 6 to 10. So let me create my variable again. So okay, let me run the function again now. So it came up. Oh, I didn't put 6 to 10. 6 to 10 rather. So let me run it again. All right. So this is what you have: minus 5, minus 5, minus 5, minus 5, minus 5. So what actually happened? As I said earlier, so let me increase my screen. If I think I should. So now, what actually happened is that here I have calculated that f has 3 parameters: x, y, and control. Then inside I have another function, mean dot base, that take a parameter z, just one parameter, and it's going to be z minus mean of control. That's what it's going to do. So I'm now saying do mean dot base minus mean dot y. This is what is going to print out as output eventually. Now, so how is it going to perform the operation? So if I should do, as I provided this, so let me copy this and paste it here so you can see everything all together. So as I provided this parameter, half, full, and nothing. Half is going to be my x, full is going to be my y, nothing is going to be my control. It's going to be my control. Now here I'm saying that mean dot base x. So what's mean dot base x? My x here is going to be the x that was provided, right? Which is half. So it is this half that will be used inside this function as z. Now it's going to do half minus mean of control. What's control? Which is nothing. So it's going to do half minus mean of nothing, then minus mean base y. What's y? Full. So it's going to take full as my z here and do full minus mean of nothing. So eventually it's going to do half minus mean of nothing minus full minus mean of nothing. That is just what is going to. I think this is supposed to be division according to what is on the screen. I think It was division. Okay, division. So it was division, not minus. But it's just the concept I want to explain, and I think I've already done that. So let me highlight it again. So let me run it. So this is what you're going to have. This is what you have. So I hope we get the explanation. So if you don't see, you are not sure whether what I said is what is actually going to do. So I'll just perform it manually so that you see that the result is going to be the same thing I have on this screen. So I said it's going to do half minus mean of nothing divided by full minus mean of nothing. You know, control is what? Nothing. So now I'll come here, I'll put into brackets. I'll do half minus mean of nothing. Then I'll say divided by, put this one into bracket again, full minus mean of nothing. Okay, so let me run this now. Can you see that is the same thing that it gave us? This is same thing as what we use with the function, the same result. So do you understand now? Any comments before we proceed? I'm not, I can't hear any comments. Hello?
Hello.
Yes, I can hear you now.
Okay.
Is that well understood? If you don't understand, but then I think in time you get to understand as you proceed. So now we are talking about the main base function. So I think I already explained that. I think I already explained this concept. Okay, this is what I just explained. Now, yeah, let me also talk about this knowledge check. I said, which of the following is the correct syntax for creating a function inside a function? Now, if you look at the first one, I said creating a function inside a function. Now, this first one, I'm saying function one is equals to what? Now, function one is just a variable name, just a variable name. Is equals to function into bracket function 2 comma arg2. Now function 2 is an argument, arg2 is another argument. It means function 1 has two arguments called function 2 and argument 2. So what is inside the function? You can see the brace. The brace has what? A statement inside it. So it's a statement that we have inside the function. You don't have a function inside the function. Now I want to skip the second one that was correct. Let me go to the third one. And the third one, I have function 1 is equals to function into bracket. Now, function 1 is the function you are creating with the function keyword, which has two arguments called argument 1 and argument 2. The argument are separated inside a comma and with a comma inside the function keyword. Now, inside the brace is what is going to define what is inside function 1. Now, inside the brace, what do I have? I have function 2 into bracket. Now, function 2 is not a keyword, it's not a function keyword. So that is wrong. This is obviously going to give you an error because you can't say function 2. How is not going to understand what function 2 is? So you can't say function 2 into bracket. Function 2 is not a keyword in R. So you are now passing a function keyword inside function. It doesn't even make sense at all. Now, going to the second one that was ticked to be correct, we have function 1, which is equal to, that's the assignment operator, function keyword, which is used to create your function, and it has two arguments called argument 1 comma arg2. Close the bracket. Then you put the brace. Then inside the brace is what is inside the function. Now inside the brace, you now have function 2 is equal to function keyword. So another function called function 2 is now created inside the function 1 using the function keyword. So it's the function keyword that's going to tell you whether you are creating another function. So that function too has what argument x as its argument. Then you have the logic statement follows. So it means you have a function 2 inside a function 1. So that's a function inside a function. So that's why the second uh, option was ticked to be correct. I believe you understand that. So it's the function keyword that is used to that. What did you say?
Oh, yeah. Thank you, function. Thank you, my own option. I suppose it's because of the five races, ba?
It's because of the what?
Okay.
You are talking about the first. You are talking about
I
the first
can see,
option.
I
Abi?
can see.
The first option is not correct because it's a statement inside the function. It's not a function inside the function.
Okay, thank you.
The, all right. You're welcome. Sorry, I just want to take a glass of water. So let's move to the last slide of this session. And dispatching to a method. So you have different methods applied to a function. Now, a function, some functions has methods, and methods are just how a function behaves. Like the find function, it has different kind of method. And how do you know whether something is a method or a function? It's so if I write a function, say function one, and I put dot something, then that something is the method of that function one. So the something is the method that the function is used to perform that operation. So for example, if I come to my out session, right, if I do print now, whenever I do print something now, let's say print 1:5. Now the result comes to the screen and you see 1, 2, 3, 4, 5, like the vector 1 to 5. You are happy. Yes, you're happy. Now, but you don't know what actually happened at the background for print to actually do that for you. Now it just applied a method to do that. So you have a method to help you do that. Now the same way it applies when you do print, let's say iris, and it prints the result for you. As you can see here, it prints a data frame for you. 1 to 5 is a vector, iris is the data frame. Now if I can also put a text, it's going to print it for me. Print, let's say hello. The result is printed. So what are the methods applied by print to do all these things? So if I do print, then I put a dot. Now you can see these are the different methods that print has, as is, by, condition, connection, dot data frame, print dot date, is a function, print dot default. Let me print dot date now. Let me now put hello. He still understood this guy. Let me use another thing. Let me do another thing. And so look at this. Look at the way how printed this using the date method. Now it printed that as what a character, whereby 1 to 5 is supposed to be a vector of numbers. So if you look at the way normal prints, printed it before. Let me just run this first time. You can see this is different from this. So you are not using the right method to print a particular object. So it's all those methods underground that the print is using to perform those operations. So date, the print function has a method date. So those are just methods for you particular. So that the ways function perform a particular operation. So also might not actually need to talk about these ones. They are not really important. Now, this is a method that was used for print a data frame. So a table was created, then you use the print.data frame method to print that variable. So also moving forward, there's also the default method for prints. You just now the default method. Look at this for instance. When they use print.data.frame to print this data frame, it printed in data frame format. And when they use the default method, they printed it in list format. This is list format. This format you are seeing is list format. So you put it in this format. So that's just. But if you use the normal print function, you just find the right method to print what you just passed to it. Sorry. So okay. Uh, I'm talking about packages. The Java program is built from a series of modules called packages. These packages are libraries of commands that take various. So inside package, you can have a package that consists of so many other packages embedded in it, and those packages are going to have their own special function of which you can use to perform specific operations. Some inbuilt function in R, we have the sum function, the main function, the what's it called? Uh, uh, I think we have the median and summary. We have some inbuilt functions in how you can use. But some packages comes with some special functions which are used to perform special operations. So you might need some packages to perform some operations in cases depending on the kind of problem you're trying to solve. You might need some special. So this, for example, we have for visualization, we have some base out package that the how that are used for data visualization, but then if you install the ggplot2 package, you find some sophisticated functions that are used for better visualization. So packages helps to improve your work and to make things easier for you. So you can use the search function to see available package, or uh, then I said when you first start, several packages are loaded on your computer by default and become ready for use. You can see the available package by using the search command, and installing packages for Windows. You can use the install of packages command and put the specific package you are trying to install, or you can just go to, I think, yeah, I don't do the manual way of having to install packages. You can come here, install, then I say package separate multiple, so you can maybe try to put the name of the package you want to install, and just click on install button. You can select a repository from here. You can select repository from here. Whenever you have an archive where you want to install the package, or if you wanted to install it from the current repository where those packages are actually being stored. If you are doing in normal RGUI, it's going to tell you to select your CRAN, but for RStudio, it's going to do it for you. So that's just long cut of doing it, but you can use the install packages to just install the particular package you want to install. In this format, say install the packages, then into the bracket, we put, let's say I want to install ADE package. I will just put it that way. So if I have multiple packages, I can put it in the C function like this and say package 1, comma, package 2. Then if I'm done, I will just run it. If I say after I can just put it like that and install all of them at once. So also you can use this way to install packages in Linux, and also this one is talking about some useful packages, and I said earlier that I can use this code to install the packages, and if you're already done installing a package and you want to use it, you have to load that package into R. And how do you do that? You use the library function to do that. I think that should show us in the left side. So here you say library, then inside the bracket you put the what's it called, the name of the package you want to load. Let's say I want to load ggplot2. I put library into bracket ggplot2. Then I'll run it. That's going to load the ggplot2 package into the R environment. Then if I'm done with it, I just want to unload it, then I can use the detach function, and I'll say package, then hyphen, no, sorry, colon, followed by the name of the package I want to detach. Then it's going to unload the package. All right, I think that should take us to the end of this. Let me see. So yeah, that will take us to the end of this session. So, here they are saying that which of the following commands now is used to see the available packages as the search command. And yeah, that's going to be all for this session. Let me know if you have a question, any question before we go to the next session. Do you have any question before we go to the next session? Hello, Faida, Titi, Mr. Tunde. Do you have any question?
No question from me.
All right. Okay. Okay. Now, let me see. So I want to. Mm, let me zoom. Let me zoom out. So this is too big. Okay. Uh. Uh. Okay. Let's just proceed. Let's just proceed. So in the next session, we'll be talking about descriptive statistics in R, and this shouldn't. Let me see. So it's going to be a lot. I don't think we are going to be able to cover it in today's class. But anyway, we stop. We're going to move on from there. So apparently, yeah, what are the objectives we'll be covering here? So here we're going to talk about summarizing data samples, how to summarize data samples, use cumulative statistics, perform summary statistics for data frames, matrix objects, and lists, create contingency tables, perform cross tabulation, and test cross table objects. Okay, so moving forward, to have some statistics tabulation and graphical way of summarizing our data. Now we have the summary command. Now the summary command, what does it give us? It gives us most especially for numerical variables, it gives us the 5-number summary together with the mean, and yeah, together with the mean. I think that's what it give us. For categorical variables, I think it's just going to give us the count, the unique count of each category. Yeah, that's what it's going to do for us. So let's see what's example in the next slide. Okay, let me just demonstrate that before we proceed on this slide. So I'll go to my R session again. Then we have the iris data set. So I want to look at the summary. Just give us an overview of how this data set iris looks like. Now, if I should run this, I can do Control Enter. Then you can see this just on my screen. Now, you can see for the separ.length column, it gave me the minimum, which is 4.3. Gave me the maximum, as you can see here, which is 7.9. And I have the first quarter, which is 5.1. I have the third quarter, which is 6.4. I have the median, which is also same thing as second quarter, which is 5.8. We have the mean, which is 5.843. So the 5-number summary is the minimum, the first quarter, the second quarter, which is the median, the third quarter, and the maximum. That's the 5-number summary. Then mean is not part of 5-number summary. So mean is just the average of that particular column. Now, also you can see everything for the numeric variables. Then for the categorical variable, you can see that it gave me the unit count of each category. So it's saying that Setosa category occurs 50 times, Then the versicolor category occurs 50 times also, and the virginical category occurs 50 times. So this gives you an overview of what the data looks like. If it contains NA that is null value, it's going to also give you the summary here, telling you the number of null value you have in each column. It's going to help you to do that too. Now, moving forward, you have some special commands here talking about the names, the row dot names, the row names, the code names, the team names. Now, names specifically works on list or data frame objects. It just gives you the names of the column of uh, the object. So if I say names into bracket iris, it's going to give me the column name of the iris dataset. Now, the row dot names works on matches or data frame objects. It gives you the row names. And the row names also work similarly as row dot names. Then you have the code names, which gives the column names, which also works similarly as the names function. Then you have the dim names, which gives you like the row, both the row name and the column name together. Now, this thing usually appear very well most of the time. So if you see something like this, I don't expect us to not to remember the ls function. You just find the name of objects used in what's it called in the environment. Now sometimes they can give you ls, they can give you objects, they can give you objects. I think there's one other one. Now, so let me give you an instance. So if I say ls, these are the objects that have been created in this out session. There's just a lot of them. Another way I can do this, I can say object, object, object. You can see it gave me the same result. So they can say what is the function that is being used to see the available objects in the R environment or variables or available functions, anything you have created at all. You can use the ls, you can use the object. I think there's still another one that you can use. I can't just get to you. So please take note of that. Now summarizing samples. Just summary statistics command for vectors. So we have commands for single value results and multiple value results. So for example, of commands of single value results, you have the mean, you have the sum, you have the maximum, the minimum, like. So those are single value results. So if I say mean of a particular vector, for example, you're expected to get just one value. If I say the max of a particular number, or a particular vector, you're supposed to get a one value. So that's what they call it single value result. Commands for single value result. They have command of multiple value results. Talking about so let's see, like the summary function. Summary command give you multiple values. Now these are single value results: standard deviation, SD, variance, mean absolute deviation, and the likes. These commands are single value command. Then also multiple value commands add log function, summary, quantile. Now the quantile function gives you the 5-number summary by default, but you can specify what you are interested in. You can say I'm just interested in the 25 percentile or the first quarter or that. Now minimum, we have 5 numbers of minimum, first quarter, second quarter, which is the median, the third quarter, and the maximum. Now the first quarter is still the same thing as the 25 or 25th percentile. First quarter means 1/4. 25th percentile means 25/100, which is the same thing as 1/4. Now, the second quarter, which is the same thing as median, which is 2/4, which is the same thing as 1/2, is the same thing as 50th percentile, which is 50/100, which is the same thing as 1/2. Please get. Now, the third quarter is the same thing as the 75th percentile. So now the minimum is the is the zeros percentile or the 100, and the maximum is 100 percentile. So like 0 and 100 respectively. Those are the minimum and maximum. So 0% is your minimum, 100% is your maximum, 25% is your first quarter, then 50% is your second quarter or your median, and 25% is your third quarter. So these are multiple value result commands because they are going to give you multiple value. Now, log can be a single value command. Log can be a single value command, but if you are operating, if you are using it on a multiple value uh, object, say a vector, so obviously I'm going to have a multiple result. So now moving forward, now here it said a sample vector data holds the following values, this set of values. Which of the following commands can be used to find the 25 percentile? Is just this. You specify quantile into brackets the data, which is this, then put 0.25. You don't write 25%, it's 0.25. So let me say, so let me come back here. I'll use, so let me run the iris summary again. Now this is the iris summary for separ.length, which has the 5 number summary together with what the mean. The mean is not part of the 5 number summary. So now let me now use the quantile function to find the 5 number summary. So I'll say quantile of iris, but I want to find just for separ.length column. So let me run this. You can see the results for this is same thing as this. Minimum is 4.3. Minimum here is 4.3. First quarter here is 5.1. What's the first quarter here? 5.1. Median is what? 5.8, which is 50%. Median is also 5.8 here. This third quarter, 6.4 is same thing as the third quarter here. Then the maximum 7.9 is 7.9 here. Just as simple as that. Now, if I just need maybe what's it called? The 25 percentile, I can say 0.25. I can put 0.25 or 0.25. So let me run it. This is 25 percentile. I can say 5.1, which correlates to what? This guy. I can say, okay, I just want the 25 percentile and the 75 percentile. I can put this 0.75 and run it. I have this, as you can see. Now, you can say I don't want the 25%, I want the 20th percentile and the 80th percentile. It's not necessary, you have to follow the format. So this is what you have. So just as simple as that. So that's how to go about that. Now moving forward, do you want to ask a question? Okay. So we have cumulative statistics. We have the simple cumulative commands and the complex cumulative command. Now let's see how that works out. Now you have the simple cumulative command. This is the cum sum, cum max, cum min, and cum pod. Though the complex cumulative command, I don't really see how that cumulative command is actually complex. I don't see how it's actually complex. But then sometimes you might want to do some trick in finding your cumulative statistics. Then that can be adding some additional stuff to it to make it complex. But I'm going to talk about that when we get there. Now, these are simple cumulative commands. And how does it work? Now, the cum sum is going to give you the cumulative sum of your vector. Say, starting from the beginning, then it adds up to the next number, until it gets to the last number. And the first of all, it picks the first number. Then the first number is going to be added to the second number. Then you have the results. Then the result is going to be added to the third. Then the result is going to be added to the fourth, to the fifth, like that, until you get to the last number. So, for example, if I want to get a vector, let me see. I want to get another vector. Let me see. let me say 1 to 10 or 1 to 5. I'm just going 1 to 5 to make it simple. Or I don't want it to be that straight. Just let me say 3, 1, 4, 3, 2, 6, 7, 5. Okay, let me create it this way. Let me call the vector so that you can see. Now this is my vector. Now if I say cum sum of VEC, this is what I get. Now what does it do? It picks the first number, return it. Then the first number is added up to a second number to have 4. Then 4 is added to the next number to have 8. 8 is added to 3, 11. 11 is added to 2, 13. 13 is added to 6, 19. 19 is added to 7, 26. And 26 finally is added to 5 to give me 31. So that's how the cum sum works. Now, usually the last number is going to be the sum of the vector itself. So it's saying that it means that 31 is actually the sum of all the numbers in VEC. Obviously, that's just the point. Now we have cum prod, that is cumulative product. That's what it means. Now cum prod, instead of addition, it's going to be multiplication compared to what we have here. So if I should run this is going to give me multiplication instead. So the first number is returned at first, then the first number is multiplied by the second number, that's 3 times 1, I have 3. Then 3 is multiplied by the next number, which is 4, I have 12. Then 12 times 3, that's 6, 36 times 2, 72, like that, till I get to the last number. So that's cumulative product. And we have cumulative mean, that's cumulative minimum. Now, in similar fashion, this is just going to be considered the minimum. We're going to check. Compares the first number with the second one and see which one is, and takes the one that is minimum. Then keep comparing until they get to the last number. So let me call it VEC again, and let me run cum VEC, cum mean of VEC. So this is what you get. Now it checks between 3, it takes the first number 3. Now between 3 and 1, which one is minimum? 1. It takes 1. Now 1 is compared to the next number, which is 4. 1 is still minimum, it still return 1. 1 is compared to 3, it still return 1, and keeps comparing to the last number and return the minimum to the end. That's why you have 3, 1, 1, 1, 1, 1, because after 3, 1 is still the minimum till the end. That's why 1 is being returned. Now, the final one is going to be cumulative max. That's cumulative maximum. That's cum max of VEC. I'm going VEC first, then one cumulative maximum. Now you can see the result of this one. First of all, it takes the first number, then compare between 3 and the next number. Which one is maximum? 3 is 3, obviously. Now between 3 and 4, which one is maximum? It's 4, so it returns 4. Between 4 and 3, which one is maximum? It returns 4. Between 4 and 2, which one is maximum? It returns 4. Now between 4 and 6, which one is bigger? It returns 6 because 6 is bigger.
You can't see your screen again.
Oh, you can't see my screen? Wow. Fantastic. You can't see my screen?
Yes.
Okay. Let me share my screen now. Let me share my screen again. Oh god. So I'm sharing now. Okay, my screen is up again. Let me know if you can see my screen now. Can you see my screen now?
Not yet.
Okay, what about now? Can you see my screen now?
No.
Wow, what's wrong?
Stop sharing and reshare.
Okay, let me try and do that again. I don't know why it's actually doing this. Oh, I'm resharing again.
I don't know if others are seeing it, but I'm not seeing it.
Hello, can you see my screen now? You can see my screen now, Abby. You can't see my screen?
No.
Or why is this not coming up? Okay, let me try and change my network to another network. Sorry, just a minute. Can you hear me? Can you hear me?
Yes, I can hear you.
Okay, I want to
Okay, I
reshare
can see
again.
your
I
screen.
think. Oh.
I
Let me
saw
reshare
it.
again.
Went back.
Yeah, I just put it off. Let me reshare again. All right. Let me know if you can see it now.
Yes.
All right. Farida, can you see my screen now?
Yes, I can now.
Okay, better. So this is cumulative max, and this is the vector, the original vector, and this is what cumulative max gave us. So first of all, the idea is the first number is returned by default. Then the first number is compared to the next number. Which one is the maximum? Is 3. Between 3 and 4, which one is the maximum? Is 4. And between 4 and 3, which one is the maximum? Is still 4. Between 4 and 2, which one is the maximum? Is still 4. Between 4 and 6, which one is the maximum? Is 6. Between 6 and 7, which is the maximum? Is 7. And between 7 and 5, which is the maximum? Is still 7. So that's max. All right. That's I think that's well explained. Moving forward, yeah, they talked about complex cumulative command, but I don't know how this is complex, because it's not actually complex. We already know what SEQ command gives us. It gives us a sequence of numbers depending on if you put an increment. If you don't put an increment, it just give us the sequence to increment by 1. So, for example, if I put SEQ 1, 10, you can see it gave me 1 to 10. It's incremented by 1. But if I say SEQ 1, 10, 2, it's going to increment by 2. So 1, then it's increment by 2 to give me 3, then increment by 2 to give me 5. Then, but it shouldn't exceed 10. That's SEQ. Then the next one you are seeing there is SEQ along. What SEQ along just does is if I say generate SEQ along, let's say VEC, it's just going to give me a sequence of number depending on the length of VEC. That's what it's just going to do for me. VEC is of length 8, so just give me 1 to 8. That's what it just does. So I don't really know what is actually complicated in this cumulative command. So it's not actually cumulative, so it's not complex. So, but it might be useful. Say for example, it might be useful in an essence sometimes, but I don't see what is complex about it. So I think okay. Here, summary statistics for data frame. So I just try to categorize summary statistics for data frames. We have the max, min, sum, 5 norm, length, and the summary function. Now, apart from 5 norm and the summary function, all of the rest are just single value command. Single value result command that gives you single value result. But 5 norm, the 5 norm function gives you the 5 number summary by default. The 5 number summary by default, that's what it does for you. So if I should do 5 norm, as I did earlier with counter here, I can say 5 norm, 5 norm of iris ampersand length and run it. So this is the 5 number summary by default. You should understand that this is going to be the minimum, this is the maximum, this is the median, this is the first quarter, and this is the third quarter. So all right. So I'll move on to the next slide. I think maybe we are going to end it here. Or let's see how far we can go. Now we have some special summary commands. The row means co-sums, and co-means. Yeah. So the row means is going to apply summary statistics on a row level, similar to row sums, and co-sum and co-means is going to apply the sum statistics on a column level. Now, let's say, for example, for this iris data set, for example, let me check the head of iris data set. So let me move this console forward so that I can see the part of the console. I want to see the first 3 rows records of the iris data set. Now, the iris data set contains 5 columns. 4 of them are numeric, while the 5th guy is categorical. Now, I can't say row sums or row means, for example. Row means into brackets iris. I can't do this. It's going to pop up with an error, because what I'm telling you to do is that find the mean for this iris data set on a row level. But by the time you get to this last row, which is species, then it's going to be confused, because I cannot find the mean of the character. So it means I can't apply row means on the whole data set of species. But let's say I want to do it for all the numeric variables in this data. It means I have to specify that, okay, give me the first 4. So I can say, okay, do it for all the records, or them just say this for this for the first 3 records for the first 4 columns. So give me the row means of the first 3 records for the first 4 columns. So if I should run this is what you have. So these are the row means for the first 3 records in the 4 columns. So the row mean from here to this place is 2.550, as you can see down here. Then the row means from here to this guy for the second record is 2.375. Then the row mean for the third record is 2.350. So that makes sense. I can say row sums if I need to sum on a row level. Then if I want to do on a column level, I can say col means, then I'll specify, okay, since only the first 4 columns that are numeric, I can say, okay, give me for the first 5 records, find the column means for the first 4 columns. So if I should run this, so this is, I can even say this for all the columns, since I'm just going to have 4 of them. So I'll not put anything in, just for all the columns. for all the records rather. So this is the average of separ.length for all the records. This is the average of separ.width for all the records. This is the average of peta.length, and this is the average of peta.width for all the records. So it's just as simple as that, and it can be very useful if you just have to do average of numerical variables in your data sets. You don't just take the average, just do co-means, and just does the work for you, and that's just it. So please, does this make sense to you at all? Hello, are we there? You said?
I want to ask you.
So what's the question?
What is used the function use method? Which one?
What's the what? Use method.
Yes.
It's not really say particular. So you just, I think it's just trying to say I want to use a particular method for a particular function. So how process a simple generic function mechanism which can be used for an object oriented style, blah blah blah. So you are trying to say, okay, use this method on a particular object, but it's not. I don't think it's that useful at all. But then you can actually specify the kind of method you want to use for a particular function, but you don't even have to bother yourself about it. Just use the function, and it helps you with the right method to perform the operation. So it's not significant per se. So I think I also explained the concept of method. I think you were there when I explained that.
The concept of what?
Methods. Talking about methods.
Okay, I want to
What did you say? I didn't hear that. What did you say?
I went to go and pray.
Oh, sorry. And no problem. You can actually go back to the recording this with that. You saw the links I sent for the past classes, so you can actually go back to watch it. All right. So here we just saw how we can use row means. So I think this was used on a matrix. This was used on a matrix. Then we have row sums, which does the aggregation on a row level. So this is going to find the mean for each row. This is going to find the sum for each row. Then you have the co-means. Then just have your usual mean, which is actually good to. So if this is used on a matrix, so it's just going to find the mean for each column. So if it's used on a matrix or a data frame, it's going to also find the mean. But if it's used on a vector, it's just going to find the mean of everything inside a vector. So that's why you can see that the result of this co-mean is similar to mean. So the mean is it's going to do your summary on a column level. So it's going to be the same as what the co-means is. So then we have the apply command. The apply command. So the apply command takes three parameters: the x guy, the margin. The x is the data is trying to work on. Then the margin is like, okay, how do you want me to do this? You want me to do it on a row level or on a column level? Then okay, what is the function you want me to apply? So you can see here, I said apply on FW. Now 1 means row, while 2 means column. So if I specify 1 as margin, it means do it on a row level. Do you understand? Then the following command the following parameter is the function you want it to apply. So it means find the mean of the FW data on each row. Now the next parameter that was included is the NA.remove parameter, which means exclude null values for each record. Exclude null values, because if you don't put this, if your data set has null value, the mean of that particular row in this case is going to give you a null value. So that's why I have to specify this. So let me give you an instance. So VEC, for example, as you can see, does not have a null value. Now I want to include a null value, please. So I want to say, okay, the ninth element should be a null value. So I'll say NA. Let me call VEC for you again now. Now VEC now include what? A null value. Now if I say mean of VEC, if I say mean of VEC, let me run this. You can see it gave me NA. It gave me NA. So to avoid this, since I can't find it, I can't perform operation on the NA, I'll tell you to exclude it. So I'll say mean of VEC, comma, NA.rm is equal to true. This aim to exclude the null value when you are computing the mean. So if I should run this now, you can see it gave me the average of the valid points in my vector. So that's what that does for you. Okay. So also we have which is the correct format to use the apply function. You have the x, then followed by the margin, and followed by the function. Then you have optional parameters that you can put. So you can see that this dot 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 was the one that made this NA.rm to be used here. So is that part of the optional parameter? If you don't specify it, you might not use it. It's not compulsory. But these three are necessary. These first three. But this dot 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 is optional if you need additional arguments. All right. Then we have summary statistics for matrix objects. And that's talking about you talk about how to use mean very well. Then I think we have talk about the apply also. If you just talking about apply. Now look at this. Look at this. Look at this guy. Now you are saying apply. You are using the apply function on the student matrix. This you have a matrix called student. So I'm saying apply on students on the row level, which is that is specify one as margin. Then give me the median. Then after it, you now put a square bracket. Now you know the apply function is going to give you in form of a matrix, right? Or let's say a vector. Let's just say vector. It's actually a matrix, anyways. So you're now saying after the apply function, you now put a square bracket, and you're now calling C into what? 1,3. Now you know the square bracket is after the apply function has been applied. Now normally without this additional information that is after the apply function, it's supposed to give you what? The median for each row. So you're supposed to have 1, 2, 3, 4, 5, and 6. Right? The median of each of them. So it's going to give you okay, let's say I think the median here is supposed to be 67. Then you are going to have 72. Then you have 82, like that. Now you now said instead of it to give you 7 records, you're now saying give me, then subset it for what? The first and the third record. So it's going to give you 67 and 82. That's just what it's going to return. Instead of it to return the 07, it's just going to give you for the first and the third record. That's what it's going to do for you. I said the result will be what? The first and third what? third subject. In this case, it's supposed to be the first and the first and the third rows, not actually first and the third subject. Though, though, if you see it, why they say first and third subject is that the median here is what 67, which corresponds to the first subject, and the median for the third record is what 82, which corresponds to what the third object then subject. That's why you have first and third subjects here. So that's why you have this to be ticked to be correct. You don't want to choose this. You don't want to choose this, the first and third rows. It's not going to give you the first and third rows. If you are saying first and third rows, you are saying that it's going to give you the whole of this row and the whole of this row. But what is actually going to give you is 67 and 82. And 67 corresponds to the first subject, and 82 corresponds to the mathematics subject. You understand?
Can I go back to the previous page?
This space.
Yes.
Okay.
Okay. So it's going to, the answer is going to be what? 67 and 82, Abby?
Yes, 67 and 82, because 67 in this row is the one in the middle. You know, if you arrange this number in ascending order, yeah, yes, exactly.
The first row and the third row.
Yes, yes.
I don't mean it was student, comma 2, comma median. Then it's going to be then into 1, comma 3. That's going to be the median for the first column and the median for the second.
Yes.
What if there is addition of that C into brackets 1, comma 3? That means just give us the whole median of 0.
So you are saying that if I put maybe 1, 3, 4 or something.
No, that's what I'm saying. I said I didn't mean I just have students, comma 1, comma median without any addition.
Okay, yes. Let's give you the median for all the records. So I'm going to have 67, 72, 82, 68, 78, and 76. Yes, some of them. Yes. Do you understand?
Okay, thank
you. All right. Now, summary statistics for list. Now, we use the apply function for data frame and matrix and right. No, for list, you're going to use what we call the lapply function. So as you can see here, you use the lapply function. Now, in this one, you specify the data and the function you want to apply on it. It's just so straightforward. It's not, you don't have to specify any magic. So for this particular list, you created this is a list here. Then you use the lapply function on this list. Then you want to apply the mean on it. So it gives us the mean of this element and the mean of this element. So for this element mo, the mean is being computed, and this one, the mean also is being computed. That's the result here, like this. Then you can also use sapply. It works in similar fashion, but the way sapply is going to return its results is going to be different from lapply. You can see the result of lapply is being returned in a list format. Now for sapply, you can see it brings in a matrix format like this. So that's just the difference between the sapply and the lapply. I say run the following command. This. Which of the following statements is correct for the command? The result output is in the form of a matrix, as you have seen in the what's it called? As you can see here, and you can see in the previous slide. Then you have contingency tables. You have contingency tables. You have different way of creating contingency table. You have the simple contingency table. You have the one that's a complex kind of contingency table. We're going to see how we can make use of that. You can use the table function to create contingency table. The table function. So, how is it useful? Now, if I have data 2, in this case, you have data 2 to be this. If I use table function on this data, now what it's going to do is that it's going to aggregate that data based on the number of occurrences alone. So it's going to give me the number of occurrence of this element inside this data. So starting from the minimum in this case, since it's a numeric data, so it tells you 2. How many times the 2 occur in this data? Once. I have 1 here. Then the next line I have 3. How many times did 3 occur here? So 3 occur 1, 2, and 3. 3 times. Then the next one is 4. How many times did 4 occur? 4 occur only twice. That's why you have 4 and you have the number of occurrences here. So it's just aggregate it and tell you the number of occurrences of it. So this works fine. So if I use this with the iris data set here, say table of say iris ampersand spreadsheet. So let me to aggregate the spreadsheet column. This is what you have. It's saying that Setosa occurs 50 times, vesicolor occurs 50 times, and vaginica occurs 50 times. It's just as this can be so very useful. It's going to be very useful. Now that's just as simple as that. Then you have the sort function just to sort your data in ascending order. So that's what sort just does for you. And sorry, just give me a minute. I'll be back shortly. So to wrap up, let me go back to my slide again. So to wrap up, I'll just wrap up on this note. Now, here you have a data frame called PW. It has height column, the plant column, and the water column. Now, if I move to the next slide, I said table PW. This is going to create a complicated, not complicated, a complex contingency table. We are not going to catch this from this picture. So let me create just a scenario for you to see. Just a scenario. Now, if I should do something like, let me just create a simple data frame. So df of data dot frame, I will say country is equals to the Nigeria, Ghana, sorry, Ghana, Nigeria, S4, let's see, South Africa. Let me just put SK for South Africa. Let me see Nigeria again. Then I'll create another vector called foot. This is going to comprise of banana, banana, apple, uh, banana, apple, um, let me say orange, let me say apple again. So I want this now. Let me call DF. So this is what you have. Oh, did I? Did I do? Okay, sorry. I just switched the first here. This is better like this. So let me call the DF again. So you have something like this. Now, if I say table of DF, then you have something like this. So what's actually happening here? It just gives you the number of occurrence of country and fruits on a row-wise basis, just compare. Okay, now what is just on the column side, it creates the unique country. Then on the row side, sorry, on the row side, it creates the unique country. Then on the column side, the unique fruits that you have in the table. Now, you now compare. Okay, how many times does Ghana and apple occur in my data frame? Now, Ghana apple, I have Ghana and apple here. Do I have Ghana and apple again? No, that's just once, one occurrence. That's why you have one here. Now, Ghana and banana, it occurred just once. That's why I have one here. And Ghana and orange, does it occur at all? No. That's why I have 0 here. Then it compares Nigerian apple. It occurs 2 times, as you can see here, 1 and 2. Then Nigeria and banana, you have Nigeria and banana to occur once, as you can see here. As you can see in my first row here. That's why you have 1 here. And Nigerian orange does not occur at all. That's why you have 0 here. South African apple does not occur 0. South African banana does not occur 0. South African 1. So this is a contingency table. This is just a contingency table. So you just aggregate your data for take 2 columns. This comparing 2 columns at a time. Now, by the time this is becoming 3 columns, then you're going to have levels. So I don't think I will be talking about that one today. So when you come for our class tomorrow, and we are going to understand when it's now get to like 3 columns. When I try to aggregate 3 columns, then you are going to understand how it's going to come about doing that. So that will be all for today. I really appreciate our presence today. I trust you've gotten 1 or 2 things in this class. So from here, we want to continue from here. Tomorrow by God's grace by 12. Yeah, and that will be all for today. Is there any question?